Hello everyone, this is Sheetal from Ballari Institute of Technology and Management, Ballari, basically from Karnataka, India country. Today I am going to give a presentation on the topic an ensemble image augmentation approach to enhance granular parakeratosis dataset. Here in this particular presentation, I am going to cover the contents like abstract introduction, literature review, methodology, then results and discussion that has been obtained from the implementation part, and finally the conclusion. This is basically the presentation or a research that is going to deal with the problem available in the medical image processing. So whenever an important step is to be taken in the diagnosis, more number of images are required. But as of now, at present, so there is only limited amount of data sets available. To overcome this one, we are implementing a particular technology for like augmenting the data set. So it is used to address the challenge of data sets for two main diseases like parakeratosis and paraneoplastic pemphigus. So the main reason for choosing these two diseases is like when the image of these two diseases are taken, it actually appears similar. So in order to distinguish between these two diseases, the particular data set is considered. So in this approach, it is an ensemble method, like it is going to take the traditional as well as advanced augmentation techniques. So wherein it is considering four types. One is a geometric transformation, generative adversarial networks, that is GAN network. Then next one, cutout and keep augmented. So once the augmentation is been done, then all the processing like segmentation, feature extraction and classification is being done. For a segmentation, a unit-based method is been chosen. For feature extraction, regionprops technique is chosen, and for classification, it's again an ensemble model, SVM tenfold model is being chosen. So when it is done, we have seen like it has achieved accuracy of 95%, sensitivity of 95%, 100%, and specificity of 100%. And the entire implementation is being applied onto the images taken from the DermnetNZ dataset. So coming to the introduction part, granular parakeratosis, it is a keratinization. Like it mainly occurs due to the deficiency of keratinization or a keratin protein in the body. And paraneoplastic is like autoimmune disease. It causes some bumps to appear on the skin, like reddishness will be formed onto the skin. So as I already told, the images appear similar. They share the common characteristics in order to distinguish between them. So the two diseases have been taken here. So publicly available dataset. So that is a DermnetNZ or a DermIS dataset is being chosen. So once it is done, so like since only few images are available on the website, so we are performing augmentation technique. What actually augmentation does is it will expand the data set by applying several transformations. So such transformation might be like rotation, translation, like flipping, etc. So here we are basically using rotation, flipping, like horizontal flipping and all. The main objective of this one is to enhance the GP and PNP. So in short form, granular parakeratosis, henceforth I will be considering it as GP, and paraneoplastic pemphigus can be considered as PNP. So main objective is to enhance the GP and PNP dataset using the ensemble augmentation techniques. So when we have increased the size of the dataset, obviously the accuracy and the reliability of the model has been increased, and it is used to determine the disease very accurately. Now coming to the literature review, so though several techniques have been considered in the research, but it is not applicable for the diseases what has been considered here. All of the researchers are mainly applying it for the melanoma disease. So also they are also facing some particular drawbacks, like if we take the first one, like rotation, flipping, sharing and zooming has been adopted by some of the researchers, but the disadvantage of this one is considered very few data set. and also like in another technique like GAN based augmentation method, so like hyperparameters were not chosen properly. Then again the third one goes with the smaller data set. Fourth one, it is not providing a better performance metrics like this. Like every paper is having some particular drawback. So, when these particular technologies faces a drawback, they are unable to handle the data imbalance efficiently. So, in order to like cope up with the data set, so we are going for the ensemble augmentation technique. So we are combining both the traditional and as well as the advanced augmentation method. And cutout is nothing but like a erasing method. So whichever unwanted things are there, so that will be removed from the image. Actually, we are considering the like abnormal part of the skin as a lesion and normal part of the skin as a non-lesion. So whenever an image is taken, we need to extract the lesion part and discarding the non-lesion part. So lesion is nothing but an abnormal part of the skin. The augmentation techniques that we have used here is like I told, both the traditional as well as a advanced augmentation technique have been used. So first one is a geometric augmentation, next one is a GAN based augmentation, then next one is a feature space augmentation, and next one is a cutout and keep augmentation technique. So in the geometric augmentation method, as I told, we are using several techniques like rotation, scaling, cropping, flipping, etc., wherein image will be rotated in the clockwise direction or in the anti-clockwise direction. Flipping in the sense either the image will be flipped horizontally or on the vertically, like any x-axis or a y-axis will be considered. Next, in the GAN-based augmentation, it is basically used in analyzing the medical images. Also, it is used to enhance the CNN performance. The next, feature space augmentation, it mainly involves two methods like undersampling and oversampling, wherein it is used to generate the more number of samples from the minority classes in order to create a more balanced data set. Then in the cutout and keep augmentation, so what first in the implementation part, what we are trying to do is first we have to extract the lesion, right? So we need to keep augment means keep the important part of the image. So what is the important part of the image is a lesion. So we are going to keep that particular lesion and then cut out the non-lesion parts. So non-lesion parts are not required, so that will be cut out from the given data sets. So once we go on applying for all this, a technique is or a model is the implementation, whatever we are doing, it is able to extract the lesion part so very accurately. Then coming to the next one, so once we are applying these augmentation techniques, the dataset move into the segmentation, feature extraction, and the classification methods. So wherein we are evaluating these particular performance metrics for each of the three: segmentation, feature extraction, and classification. The first one is accuracy, next one is a specificity, next one is a sensitivity. So how the accuracy is measured is TP plus TN divided by TP plus TN plus FP plus FN. So wherein TP indicates true positive, TN indicates true negative. So true positive means the lesion is correctly identified as lesion only. True negative means lesion is incorrectly identified as lesion. Then again we are having false positive and false negative. False positive means non-lesion is incorrectly identified as lesion. False negative is incorrectly lesion. Non-lesion is incorrectly identified as non-lesion. So using all these four particular terms, we are going to measure the accuracy, sensitivity, and specificity. And the specificity is measured by like Tn divided by Tn plus Tfp. Sensitivity is measured by like Tp divided by Tp plus Fn. So using these metrics, we are performing the implementation for all the three: segmentation, feature extraction, and classification. So going in detail about the methodology chosen for the augmentation. So for the actually there is a built-in class or a built-in function available in our Python. So the programming language used for implementation of this particular model is using the Python. So we are having a image data generator. So wherein we are using few techniques like horizontal flipping, random rotation, shift, rotate, and random zoom. So in the horizontal flipping, we are actually flipping the image around x-axis. So for this one, so we have to make use of the flip function that is available in the CV2 library of the Python. So wherein we are passing the second argument as 1, which indicate like we are flipping the image around the horizontal image, it's a x-axis. Next, random rotation. For this one, we are again making use of, we are going to create a transformation matrix, so which is required for rotating an image. So for that particular purpose, we are again making use of a CV2 library, so which has a built-in function like got rotation matrix. So for that one, the number of columns, number of rows is passed as an argument. Then next, shift shift actually we are shifting the image by 20% of width of the image as well as 20% of height of the image, so that wherever the lesion part is there, so that will be considered over here. Next, rotation. The image can be rotated between any degree from 0 to 360 degree. So here for this particular implementation, we are rotating the image to like 40 degree. Therein we are obtaining the given result. Next, zoom. We can either zoom in on an image, or we can also zoom out on an image. So here we are actually zooming in on an image, wherein we are taking the value of zoom as 0.2. If it is greater than 1, it will zooms out an image. Then in the advanced augmentation techniques, we are making use of the cutout and keep augment. So cutout actually takes two parameters. The first one is nothing but the number of patches, and the second specifies the length of each patch. And in the keep augmentation, so as I told, it is used to keep the required part of the image, like lesion part will be kept, and once the lesion part is kept, we will apply the cutout in order to remove the non-lesion part of the image. So these are some of the augmentation techniques that have been chosen here. So coming to the uh, overall process of the model, first we feed the original data set, then ensemble image augmentation will be applied, so more number of images are generated. The segmentation is performed using binary cross-entropy loss function of unit. Then feature extraction, like size and depth extraction, features have been extracted using region proximate. Finally the images are classified into two, whether it is parakeratosis or the pemphigus. And then the performance metrics have been evaluated, like accuracy we have got like 95%, sensitivity of 100%, and specificity of 100%. Now, as we can as a proof, we can see here we are having the original data set of GPS 1505, but once we apply the augmentation, we are obtaining it like 75,250. Even pemphigus, the original data set consists of 99 images. After augmentation, it is something like 4,950. So it's a great achievement, so more number of images have been generated here. Then coming to the parameters that have been used in the implementation technique. For the augmentation technique, so as I told, we are applying rotation, shifting, zooming, flipping, etc. So horizontal flipping is set to true in the sense that the image has been flipped horizontally. And the rotation image, the image is being rotated to the 50 degree, and width and height 20% of the image, as I told. The zoom is also 20% of the given image. Then GAN based values, geometric adversarial networks parameters. So for convolutional layer, we are using the activation function like ReLU, rectified linear unit function. And for the dense output layer, we are using the activation function like linear activation function. Then in the cutout implementation parts parameters, the cutout value what we are choosing is 0.5. For erasing the region against the input image, like minimum, for everything we are choosing the minimum value and the maximum value here. For erasing the region, minimum value is 0.02 and the maximum value is 40% or like 0.4. Then the aspect ratio for the erased region is 0.3, and that is a minimum value. Maximum value is 3.33. Then again coming to the minimum value for the erased area, it is considered to be 0, and the maximum value is 255. That means the entire image will be taken and find out the lesion and non-lesion parts in order to check whether it is able to extract the lesion part or not. Then once we go for a segmentation and the classification, we are choosing several parameters here like optimizer, so which is used as a Adam optimizer, the learning rate, it can be between 0 to 0 to 1. So the lower the value we choose, so the higher will be the performance. Then batch size, so within one batch 18 samples have been considered and it has been tested for two number of epochs. The loss function that is used for the segmentation is binary cross entropy, and for the classification it is a hinge loss. So why hinge loss is, it is considered to give a better accuracy. It is able to classify linear one and the non-linear one, that is lesion and the non-lesion lesion. So it is actually considered like for classification, SPM is being considered. So that is a binary classifier. So since we are having only two data set here, so that is a GP and PNP, so we are considering only the binary classifier. If we are having a more number of images, then we can go with the multi image classifier. Then once we have done, so like we have also compared the performance before augmentation and after augmentation. It is observed like before augmentation the accuracy was around 85, sensitivity was around 91 and specificity was around 89, but after augmentation it is drastically improved by 95% and 100% for both accuracy as well as the sensitivity. So even when compared the proposed methodology with the existing techniques, like so several references have been taken from the paper. So in that one we can directly observe like accuracy is around 85%, 91%, etc. But our model is able to obtain 100%, 95%, and sensitivity and specificity is also able to obtain around 100%. So these are some of the augmented data samples that has been obtained after flipping, rotating, etc. And this is a graphical representation like how the accuracy is being obtained. Then coming to the conclusion, so due to the scarcity of a data set available, so we are going to implement an augmentation technique where it is going to enhance a data set. So here we are making use of the ensemble model, so wherein it is combining both the traditional as well as advanced methods. So the traditional method like a geometric and GAN based method, and advanced method like cutout and keep augment method, wherein only the lesion parts has been extracted here. Then once it is done, the model has been tested on two particular data sets like DermnetNZ and DermnetNZ dataset. So once the segmentation, feature extraction, classification have been done, the model has shown a very better improvement with respect to the accuracy of 95%, 100% sensitivity and 100% specificity. So the model has also been compared with the previous papers. Again, it is proved to provide a better performance. So even before the augmentation, the performance is considered. After the augmentation, the performance is considered. Still, there is a drawback like only 95% accuracy is being obtained, but that can be improved to 100% in the future research. Also, we can explore the general usability of the augmentation techniques in so several others like other domains. Thank you.